Sex-linked traits are traits that depend on alleles found on the X and Y chromosomes. They carry special properties because they are linked to the chromosomes that determine gender, and so they can be tied to one specific gender more so than another. One specific example of a sex-linked trait is colorblindness. The allele for colorblindness is located on the X chromosome. It is recessive, and colorblindness is found more commonly in males. This is due to its recessive nature. Females who carry two X chromosomes often have a normal or wild type allele that can mask the negative effects of the colorblindness allele. However, males who only have one X chromosome have no way to mask the allele that they get, and so colorblindness is more frequent.
Did you understand that part about sex-linked traits? If you want to see an example worked out of a Punnett square cross, click here. If not, keep on watching. We have more examples.
Another example of a sex-linked trait is hemophilia. Hemophilia was called the royal disease in 19th century Europe because it was frequently found in Queen Victoria's royal family. In this example, the father at the top is a normal father with a dominant normal allele. The mother is a hemophiliac mother with one recessive allele on each of her X chromosome, giving her two mutant alleles total. From a simple Punnett square, we can gather that all of the girls will be carriers, but they will not express the trait because of their normal X allele from their father. However, all the boys will have hemophilia because they inherited the Y chromosome from the father and the mutant H allele from their mother. They do not have another copy of the normal allele to mask this hemophiliac allele like the girls. The genotype ratio for this will be 50-50, so that's 1:1 because the only two possible genotypes we have is the carrier girl genotype and the hemophiliac boy genotype. The same goes for phenotype ratio because we can only have either carrier girl or a hemophiliac boy, so the phenotype ratio is 1:1 as well.
Another example is pictured here with muscular dystrophy. See if you can work through this Punnett square on your own.
This is the key to understanding a pedigree. Males and females are represented by either a square or a circle, respectively. Colored-in squares and colored-in circles represent an affected male, meaning they have the phenotype in question. Here you can see an example pedigree. Do you know what type of inheritance this represents? Is it autosomal recessive or autosomal dominant? Let's see. It turns out that this pedigree represents an autosomal dominant trait. Thus, we can fill in all the people unaffected by this allele as little r, little r. We also know that the genotype of all other individuals is either big R or big R little r. So let's make a Punnett square of our generic cross, heterozygous cross heterozygous. This leads to the 1:2:1 ratio that we are so familiar with. Looking at this, we can see that any parents that have a homozygous recessive child must have a carrier as one of the parents. For individual number 4, it must be heterozygous because one of its children is homozygous recessive. Individuals 1 and 2 both also had a recessive child, so thus they are both carriers for the allele. For all other individuals, they are either homozygous dominant or heterozygous. Thanks for watching. I hope this video tutorial on genetics was any bit helpful. If you have any feedback, let us know in the comments. Anyways, have a good day.